Cheers.
Cheers. So is it live already? Everyone can hear me?
Absolutely, yes.
All fine.
Awesome. Great. So, yeah, since this is Aces at Home, if you hear a cat or a cat by accident disrupt something, just ignore it as a part of presentation. Actually, this little bastard was sleeping for last 3 hours and now he woke up. You understand how it works. So I consider myself lucky because I was actually on one real live conference this this year, and thanks for Johnny and Christian for doing this, because it is, well, at least this we can do to try to cope with the current situation. So at the beginning, before I start, I want to share a short story with you. I think 12 or 13 years ago, where the smartphones were just the new things on the market, a friend of mine bought a new smartphone with early version of Android or Linux. Don't remember exactly what it was, but it was awesome. I remember I had a Nokia, and he had this new awesome smartphone, and it did all those cool things, like when he shook it, it moved. You know, the sound of the cow. He shakes the phone and the phone goes moo. And it was awesome for us. You know, we were so entertained by this new tech thingy. But well, there were some problems, of course, also, because when someone called my friends, there was no answer button. Well, why I'm talking about this? Because a year ago, we decided to implement a very new technology called Oracle Exadata Cloud Customer. And we were very excited about it. But in most of the cases, it lacked answer button. So we spent a few months trying to get this new cool software to work. And we actually managed to do this. The other one. So we actually managed to do this, and everything worked peachy until, of course, the performance tests. So one of the companies migrated a database from an old system to the new Oracle Exadata system. And well, they reported that the performance is much, much worse than at the beginning. And well, we were not very surprised, because we had a lot of problems with the original product whatsoever. So we, of course, said, yeah, okay, we knew it will happen. It will be like this. We knew it will happen. So we just checked AWRs. We just checked the regular Oracle database performance. We checked the ASH reports and so on. And it has occurred that the database is actually peachy. You know what I mean? Regular, normal story as always. If something is wrong with the database performance, it's database fault, right? App is going slow, it is a database fault. Report slow, database fault. You have lags in your app, database fault. Car won't start, database fault, and the rain and everything. Probably the current coronavirus situation, also some kind of database fault. So as we approached the actual the actual performance tests on this new Exadata Cloud Customer system, we noticed that actually from database perspective, everything is quite cool. So please now join me in simulating this kind of situation. I'm sure there is a way for me to share something. And here it is, share. Cool. I hope you can see my desktop right now.
Yes, it's all fine.
Awesome. Great. So let's simulate the situation I described. Right now, I have two databases, a local database, the old database on my VirtualBox with this IP address, and the remote database to which I'm connecting via VPN connection. This is my new server to which I migrated. This is my old server. Those databases are 18C Express Edition databases, both. So nothing fancy, nothing complicated. And to make sure that my old database is a bit slower than my new database, I will use one trick. But first, let me open Python to simulate an app, because, well, the situation I'm describing is related to the Python model used by the customer who was migrating to the new Oracle Exadata Cloud customer. So I will use Python 3 and set the CX Oracle model to imitate an application behavior. Okay. Now I will connect to my databases. So I have new DB and the old DB. Both will be executing this SQL, and for both I have created two cursors. Awesome. So now let me make the old DB a bit slower than the new DB. Sorry for that. And username is HR. Awesome. First of all, I will log in to root to my old DB, and I will use cgroups to throttle I/O a bit. So my table is located on DM2 device. So I'm going to throttle DM2 to 10 IOPS only, block I/O, throttle, read IOPS device. And I will throttle it for this as speed and enable a daemon. Why I'm doing this, you will see in a second. So right now I'm going to run this query 10 times on a new DB and an old DB in order to compare a performance and check the performance from an app perspective and the performance from the database perspective. This table is a bit bigger than usually. I made it 3,424 rows on both systems, as you can see. Additionally, to make sure that both databases are performing equal, are doing the same explain plan and the same execution of the explain plan, I set serial direct read to always to force both databases to use direct path read for the table. And I set file system IO options to set all on both databases in order for those databases to use direct IO and async IO to the file systems. Okay, now since my throttling should work by now, let me test this cursor, execute for this query, fetch all for 10 times. Okay, so we had 20 seconds for the new DB, and let's check the old DB. Only 3 seconds. So for the old DB here, my SQL executed 10 times in 3 seconds. And for this DB, my SQL executed 10 times in 20 seconds. So let's now compare the executions from a database perspective. So this is my brand new server, much better than the last one, right? And when I browse AWR or Ash reports or just query a database, just query a simple VDOL or SQL view, I can see that a total execution in milliseconds for 10 executions was 85 milliseconds. Because elapsed time in VDOL or SQL is in microseconds, I have to divide it by a factor of 1000 to get milliseconds. So I had 8.5 milliseconds per execution. And this is much, much faster than on my old database, which is something I actually expected, right? So I can see that on my older database, elapsed time per execution in milliseconds was 279.9707 milliseconds. Quite a lot. Very big difference in the terms of database performance. But when I see, when I look again at my application performance, I can see that I can't notice that my new database is much, much faster than the old database. The question is, why? So before we proceed, we have to explain one thing: the difference between executions and user calls, in order to be able to notice if my application is a chatty app. So in $stats, we have two statistics that can be reflected in the load profile in AWR reports: user calls and execute count. So I will show you right now AWR reports from our performance tests on X7. Bloody tech. Give me a second. Now, much better. So this is real application cluster on Exadata Cloud Customer, as you can see. And let's proceed to our load profile. So in the load profile, you can see a statistic called user calls and executions. And we can see that both user calls and executions are quite close together. Those statistics from user profile actually corresponds to those stats in the sessions. We have user calls and the execute count. And in our case, as you can see, user count and executes and user calls and execute count shows that execute count is much lower than the user calls. So again, what is the difference? In order to understand the difference, let me show you how Oracle is actually performing execution of a query from a network perspective. To do that, I will open Wireshark to grab packages on my VPN interface. Okay, so this is my filtering, and I will
Apologies, everybody. We seem to be having some networking difficulties from Kamil's side. We can still see him as being active, but somehow he's not here anymore. Johnny, anybody of the other admins can see something?
Work in progress.
Yeah, exactly. Yeah, someone said Wireshark killed VPN and Zoom. Well, it could actually be, yeah. Let me see whether I have his phone lying around somewhere. Is he? No, he just left.
I'm back.
Yeah. I
Okay.
reconnected.
For that.
Okay.
Yeah.
For some reason, I lost my internet connection for a second, but I'm back. This is why clouds are problematic, right?
So, Kamil, just for your information, people were saying that they couldn't see the AWR report.
They couldn't see it.
Okay, only the console is visible.
Okay. Once again, let me go.
You probably have to share your desktop and not just the window.
Yep. Wait a second. Share. Desktop. Sure. What about now? Is it visible?
Yeah.
Cool. So again, sorry for that. Sorry for the break. Here you can see user calls and executions in the user profile, and you can see in AWR report that those are very close together, right? So now we will try to explain what is a user call and what is an execution. So sorry, I have to connect once again here. Awesome. And let me re-establish my connections once again. Cool. Now I will also create. Okay, let me just go through all the timeit things. So timeit, lambda, and this is my new execute. I want you just to see everything back on screen. Fetch all, and number was 10. Cool. Awesome. And the old DB. Awesome. Great. So let me just show you. Let me just show you what is the difference between between the execute count and user calls. I will create a new cursor to read a smaller set of data. For example, it will be select star from departments. Great. And now I will just execute a new DB to get all from the departments. And let's check our Wireshark. As you probably know, Wireshark is a tool to capture network data and to show the packets that are going back and forth. So I'm filtering my network track to the IP address 10.0.0.8 for TCP port 1521. And here in my first TCP packet, I can see that my session sent data to port 1521. As you can see here, the destination port is 1521. And in my packet, I see the text of my SQL that was sent to the server. Now, the whole idea is that the network packet has layers, like Augurs has layers and Onion has layers, right? So I can see that one of the layer here is a TNS layer. This is an app layer, which sends MySQL text. Now the server is responding, and the first response is based on is described as describe information. So at the beginning, the server is responding with a description of the columns that will be returned, the data types, the headers, and the first data. So then my client says acknowledge. So it says, okay, cool, dude, I got it. I have everything I need. Now, please send me more. So I'm sending request data. As you can see, the request data is described as user OCI functions. So now the server says, okay, this is your data. And at the end, it says no data found. So this is all the data I got. I have no more data. Stop asking me for more data. So based on this information, my process server knows that it should know that it shouldn't ask for data anymore. So there's one awesome thing going in here. Just before the end of the data, there is an end of the data flag for this particular client. It's that there are 2 bytes, 7B05, and 6 bytes later, there is a 1 byte indicator, in this case 03, which means that the server says, okay, dude, I remembered your open cursor at a slot number 3. So what happens if I execute this query again? So I'm executing it again. My request data says only, this was the end, it's 03. So my request data says only one thing and one thing only. Execute a query number 3. Then a server responds, okay, those are the headers, those are your data. Again, no data found, and information, this query is still at slot number 3. If I execute another query, like for example, from select star from locations, again, at the beginning, I am sending SQL text. At the end, Oracle says, cool, I remembered your query at slot 5. So once again, if I execute this query again, my client says only, please execute a query on slot number 5. Here's your data. They're still on slot number 5. So this is how Oracle actually manages the whole open cursors thingy. Okay. And execution is the single SQL execution. So this is execution right here. If we check SQL stats for execute count, you can see that executions rose by 1 for this query. But because my client session, after executing, while asking for the data, executed also at the low level more OCI calls, the user calls rose by 2. Right? So execution count is literally the number of SQL executions, while user calls is the number of low-level calls that a user executed in the driver to in order to execute the whole query. So in my case, the execute count, the user calls are combined with the number of fetches that my client is producing in order to get all the data. When you have a new cursor in all drivers, you have a number of rows that a driver is fetching once at a time. So in Oracle, in say CX Oracle, by default, there is a parameter called array size, which by default is set to 100. But in most of the cases, 100 rows is not enough to is the number that won't fill the whole packet. So this is not the optimal number. This is not an optimal number of rows per one fetch in order to get all the rows that are needed, all the packets that are needed in optimal user calls scenario. Let's see what will happen if I create a new cursor . So new DB user and new DB cursor, and set array size, for example, for 1000 from 100. So to remind you, this was my old cursor execution. Awesome. So the number of execute count rose by 10, but user calls, well, rose drastically. But let's see what will happen if I use my new cursor with changed array size. Suddenly everything works much better. And from the database perspective, I can see that again, execute count rose by 10, but user calls rose by 50 instead of some sick number, like 400 something, right? Almost 400. So array size means fetch 1000 rows at a time. And those 1000 rows can actually fill my packet, since now my packet size that is returned from server to me with the data is 1402 bytes. And my maximum and my MTU is of course 1500. So this is almost maximum usage of my TCP packet to be sent to my client. Now the difference between the new database and the old database is not as big. And as you may expect, the whole difference in this execution from the customer perspective, from the client perspective, is the network latency. So if my new server is a few kilometers away, each and every packet can be delayed by the milliseconds. And if I use a chatty app, if my app is executing a lot and a lot user calls in order to get the same data, I will get a delay like 30 milliseconds times the number of the user calls. And I won't be able to see it from AWR, from a database perspective, because the time showed in the database is not a time that an app can see while fetching the data. So while we were facing this problem, we asked ourselves two questions. First, how can we spot a chatty apps just like that? Well, one of the things that you could actually do, now let me check for hanging processes, maybe it's, okay, straight. Okay, so now one thing that you can actually do, for example, if you have okay. Articles, Oracle presentations, hours from 1 week. Okay, so you can use a FlashDBA scripts to generate a set of AWR reports, and you can use my tool called AWR Analyzer in order to generate a pretty HTML charts to see what actually is going on with your application across the time. So once we have it, we can focus only on user calls and executes. And in here, we can see that this is a chatty app because executes and user calls are quite close together. The only difference is when the app is processing at night, where user calls and executes are a very different thing. And why? Because at night, the application is actually using a lot of PL SQL and a lot of processing at the database level and not processing at app level using Python. So this is the whole SmartDB thing that a lot of people are talking about. And the other thing, when you spot that you have a chatty app and you want to actually diagnose the sequels that cause the most problems from an app perspective, AWR may not be enough because you can see top sequels by user IOs, by elapsed time, and so on, but you won't see what is going on from an app perspective. So we, in our company, Nora 600, we wrote a tool that can help you with diagnosing the SQL performance from an app perspective. The tool, well, actually all tools that I'm talking about here are accessible from GitHub. And the first one was here in AWS Create repo. It was AWR Analyzer.
Either he is thinking really hard right now, or we just lost him again. Kamil? Hello.
What was the last? What? Hey, hello. Wait a second.
Yeah, you are back online. Please go.
I'm back online. You can hear me?
Yes.
Yes.
Awesome. So what was the last thing I said? No, you didn't listen.
Well, you got us.
Okay. So probably you had that
Lasse says the last showing was the GitHub repo.
Great.
Yeah.
Thank you. So on GitHub, you can find all the necessary tools and how can you use them. So let's just do everything once again. So Python 3 import CX Oracle. We'll connect to a database. I will just connect to one database right now. This is first cursor. This will be my second cursor. Array size is 1000. And let's make it happen. So I will use TCPDUMP to show to dump the whole network from my app client to a database. And I will save it as a pickup.
Kamil, I don't know if you can hear me, but we seem to have lost you again. Hello, Kamil? Yeah, it looks like he's gone. Video's gone as well. We can still see his screen though.
Hello.
Yes, we can hear.
Okay.
Yes, you're
Okay.
back.
Back again. Awesome. Johnny, can you please stop doing this? If you want to tell me something, just do it like a man, okay? Okay, so again, I'm connecting to the database, creating a cursor. Creating a cursor, a SQL text, and a new cursor, and a new SQL text.
Kamil, you're not sharing your screen.
Christian, thank you.
That's what I'm here for.
So desktop share. How about now? Better?
Yeah, that's good. Somebody just suggested you turn off your camera and only do the screen sharing so that there's less traffic on your line.
That's a very good idea. Thank you. Okay, I can drink beer without anyone seeing me now. That's cool. Maybe I shouldn't talk about it also. So my new cursor will have the bigger array size, right? And I will execute time it lambda cursor new db execute SQL text fetch all number 10. And again, for the old one, awesome, cool. So I have my TCPDUMP in here. Now I can use my STADO written in Golang in order to analyze my traffic. Cool. So what can we see in here? To use STADO, we actually we are showing a pickup file, interface IP address, and don't worry, you can specify with a comma a few database addresses, and a port as a filters for pickups. STADO locates, like we saw in Wireshark, packets, locates SQL text, generates a SQL ID, and then it shows the following data. For now, it shows ratio, and this is how much time SQL spent in app versus on the network traffic. How many executions of a query there was. What was the in each time the same or not, and average time spent in application, standard deviation network, also average time spent on the network, how many packets were used to execute the query, from how many sessions, and how many times the cursor was reused. So here you have reused cursors. So in here we can see that my cursor that executed much faster from an app perspective spent only 66% of its time on the network, while the slower one spent 94% of the time on the network and used almost 4 times more packets to deliver the same amount of the data. So you have possibility also, of course, to sort the output by ratio, by elapsed time, by and executions, packets used, round trip time, so network elapsed time, and so on. And based on this report, you could actually say if your app, when your app is a chatty app, based on this report in the TCPDUMP, you could show which SQLs are the ones that are used heavily by your application. And maybe you can either ask your dev team to transfer the SQLs to the database level and just use them in PL SQL, or to do a simple thing like trying to expand the array size and fetch more records at one fetch. So actually the cloud thingy starts to look very nice, because it actually changes everything. Like, developers have to start thinking again about the network performance, about the data size, about the correct usage of the data. So maybe all those troubles we have with clouds as DBAs, maybe it will force most of the developers to start thinking again like they were thinking about app and the data in the times when network was not as fast. And for people that actually want to deploy apps and databases in cloud environments, and not only cloud environments, but the remote environments, please always do network performance testing, and always check if your app is a chatty app, because there is a simple way of calculating the performance penalty you will gain after migrating to some remote destination. So thank you very much, and that's all.
We do have several questions in the Q&A section, Kamil.
I see only one. Okay, I see more now. Wait a second. Yeah, okay. What is the size of open cursors cache on the client OCI side? What defines it? Okay, so for example, is the size of open cursors. Okay, so the things I'm discovering right now are based on my network profiling. It's not reverse engineering, not at all. And right now I can see that this is only 1 byte that specifies the slot number. So if this is 1 byte, the maximum amount is FF, so 255. And when I was performing testing, I saw that after going by this magical number, Oracle caches it once again from 0. So for the drivers attested, this is 1 byte FF, so 225. So is asking, watching in trace for SQLnet message from client inside the cursor execution could be an indicator. No, I guess the average weight should increase in latency increase for this kind of chatty app, even if in general it's considered an idle event. Yes, is correct. If you perform, but you would have to perform actual session trace and get all the traces to figure this out. But either way, it would be very hard, if not impossible, to get an actual information how long the application waited at the app side. But yes, watching the trace for SQLnet message from client could tell you something. I personally believe that using TCPDUMP analyzing and combining it with AWR statistics like executes and user calls can lead you to the answer faster than tracing the whole database. Andrea, the question is, Kamil, thank you so much, and you're welcome. 2 questions. How far was the new EXA-CC with respect to the old database from the application service? It was not far away, not more than 12-15 kilometers. So it was, the difference was, well, it was a dedicated fiber channel connection, and it was like 10, 12, maybe 15 kilometers. And the difference was like tens of milliseconds, up to hundreds of milliseconds, sometime in a spike, because of all the switches and firewalls on the way. But only tens of milliseconds of difference, only a few milliseconds of difference with a latency can lead to a serious performance problems, like with fetching 1 row at a time. Row by row is slow by slow, and packet by packet is, yeah, the same. So the next question is, I have tested a similar analysis with your STADO tool, but have had problems.
Kamil, just quickly, I'm sorry to cut you off. Okay. Could we take the questions that are still open into written mode, so that you okay, just type in the answer, because we got Fritz standing by, who's about to start with the next presentation.
Okay, great.
If that is okay for you.
Thank you very much, everyone. Thanks for listening, and
thanks so much, Kamil.
Hi, Fritz.